So here's a little look back at what things looked like a couple of years ago. The building on the right is my original shop building. The building on the left is the add-on that I did in, I think, 2021. And you notice there's a gap between the two buildings there. It's a 7 feet wide by 50-foot strip. The blue rectangle represents the new building, and the plan was to close, connect everything together, and then close in that gap between the two buildings to create just a breezeway internally. But it proved to be the source of a lot of flooding and leaking issues. Yeah, so you can see how much water was actually coming off there. And you can see the new building, the roof was not even on that yet. And so once the roof gets on that, the water spills off onto the two other buildings, and then even more water is coming down into the center. So this video is a couple years old now, just kind of showing what it was looking like in the middle of trying to do all this. And I'm not trying to blame the builder. This really was my fault because there was no real master plan. I just started adding concrete and let's throw up a building and, try to get it all, all integrated in. And so now we're just left with this one breezeway area that's got some leaking issues, and we're getting that solved. All right, so this J-trim panel right here, or where the R panels go into the J-trim, is where the water is coming out at. It's just coming out over that edge right there and coming down. And so we've made some attempts to try to fix this unsuccessfully. So we're just gonna put an internal gutter in here. And so I'm just gonna come down like about 2 inches from right here, and then out about an inch. Let me get this where you can see it. And then back up, and then have a little flange that can screw to that, and then slip back up in behind this in there. So we're gonna use the big fancy brake for that, so let's do it. All right, so here's kind of what I'm thinking on this. We wanna, up against the wall, we're gonna come straight down. We're gonna have like a 2-inch section like that. And then out from the wall, maybe a 1 inch or inch and a half, we'll just say 1.5. Then we're gonna come up at an angle because that water kind of splashes out. And don't really know what that angle is right there, but it's probably gonna be 115, something like that. And then whatever the difference between 115 and 180 is, we'll have that same angle to get us going back up parallel like that. And then we'll come out with a flange like this, and then we'll have a screw going in there. So hopefully that's legible and readable for you. Zoom in. So if you notice, there's a gap between, if you draw a line right there, that's the ceiling. So this flange right here is gonna stick back up behind the J-trim and allow this to come flush. Now, these dimensions right here, we don't really care if they're perfect. We don't even really care if the angles are dead on, what we're trying to do, because it's 26 gauge material. We can form it, we can push it, we can jam it. But I wanna show you how on the brake, you can do manual programming when you have a job like this without having to go to CAD and draw something up and all that. And then when we get done, we're gonna make an end cap that's gonna look something like this, and then have flanges that wrap around the edges right here. And we will do that in 3D and program that and show you that. All right, here's a better look at that sketch. So we have a total of 4 bins, and we're gonna start by programming this 0.75 flange right here. So the order of this, could be important. Maybe if you do one before the other, you can't get the other one bent. So something to think about on that. That's a nice thing about importing something 3D. The bend simulation on this will figure that out for you, and you don't have to fool with it. The other thing about, doing NC programming like this is, let's say this bend right here was, this leg right here was off by a little bit. So we need to make that a little bit longer coming out here to fit, this part of what we were trying to fit. And if we do that, then it affects these two. So if you're just making simple 90-degree bends, you know, you can make tweaks and, you know, it's no big deal. But when you have the more bends in the part, the more complicated it becomes to try to dial in things manually. Again, I'm showing you how to manually run this brake. Obviously, this is a 8+1 axis full 3D CNC forming center, and you know, you can import a 3D model, but for this we're going to show you that. So anyway, all right, so right here we're just going to go new program, and so that gave us a blank format where everything's blanked out, and so we're just going to kind of run through this. So right here you can tell it, you know, how many total pieces that you're trying to do. We'll just put a number in here. We'll just say 20. And how wide is the part? It's going to be 10 feet wide, so we're going to say 120 inches. Whoops. We'll leave it at 12 for right now, just to demonstrate one feature. So how thick is the material? It's 26 gauge. I think that's 01. I don't remember what it is. 0.016, something like that. So what material is it? So you got a material list. It does matter. So we're gonna pick just regular steel. And our punch and die combination here, it's already set from what it was at the factory. So we have our 86-degree punch, and that's a 1/2 inch V opening. That's a 3/4. Since we're doing thin material, we're going to use the smallest one we have. And you can see this list of dies is what comes with the machine. So you got 1/2 inch, 3/4 inch, 1 inch, and 2 inch that comes standard with the machine. So if you wanted to select a different one, you know, you would just pick it here, and then right here it shows you a little diagram of it, and then you would say insert, and now that's in there. And it, you know, it's V12, but it shows you the actual decimal equivalent. This machine is metric, but we have it converted to inches, so you'll see some things that kind of still have metric sort of history to them. So anyway, so that's the basic setup on that. The angle, so we're going to start right here with this flange, and so that angle is going to be 90 degrees, so we're going to put that in there. And if you notice, we have 2 spots for the angle, Y1 and Y2. So this is cylinder Y1 and this is cylinder Y2. You can specify, you know, so you have 8 axes. That's one of the advantages of this brake compared to a fabricator, is you can specify the angle on the right and left side to either correct a problem with an angle, or if you want a tapered angle, you know, you can do that as well within reason. Of course, you can't get the thing all crazy lopsided. So X-axis is our in and out movement of the back gauge. So we're gonna put 0.75 right there. And if you notice, we have X-axis here, you know, X1 and X2. So you have two sets of back gauge fingers. In fact, so if you see the position of them now, they're way over there. So I'm gonna go ahead, based on what we have programmed so far, I'm gonna go ahead and bring those up, and I'm gonna hit start right here and watch them come up. So those have come up there for a 12-inch wide piece to be formed. All right, so now let's say that we want to go back here and put 120 inches in this for our 10-foot wide piece. All right, so now we have 120 inch. All right, and so I'm gonna go back and hit the green start button. And now they're ready to take 120 inch, a 10-foot piece basically. Now, you see that automatically adjusts based on what material you program it for. You can manually override that. The Z1 and Z2 are the axes for that. You can see this is at, so the numbers on the screen, that's 0, and this is 120 for 10 feet. and you can kind of see where it puts them there. You know, if you wanted this one, if we wanted, well, let's put it back at 12, just so we can see it better. And I'm gonna go here, I'm gonna hit the green start button. All right, so you see where they are, and it's, you know, it's splitting them equal between the material to try to keep you in the center of the brake. But let's say, you know, we want to get, we want to leave that one where it is and move this one over here, because we actually are going to do that in a little bit. So now you're talking about the programming of Z1 and Z2. That's your left and right axis. So we're going to leave Z1 where it is, and we're going to put, let's say 95 inches right here. So now we have that, and so I'm gonna go over here, I'm gonna hit the green button. Again, NC manual programming. If you can program all this stuff on the brake, the 3D part of it, and running the actual brake is pretty easy. All right, so we're gonna finish programming our part here. So this was 120, and so we have 3/4 inch, and then, you know, so you have your angle corrections are here, and corrections on the x-axis are here. You know, again, manually done. If you use a 3D model, it'll calculate all this for you. So you have more information right here. TDC is basically the equivalent of opening height. So after the ram cycles and comes back up, how high does it come back up? Obviously, when you're doing production work, you don't want it coming all the way back up and all the way down. You just need it up enough to get the part out. And so you can program that manually. Again, if you do this in 3D programming, it will figure that out for you. So it's calculating the tonnage right there. And it's calculating the crowning. So if you see right here, we have our crowning servo hanging off the end. It's not a lot of crowning compensation that it's needing to do, because the material is so thin. Obviously, 10 feet of 26 gauge taking 3.5 tons, basically nothing. You can control the speed of the ram right here. You know, the mute position is where the brake slows into the forming cycle. You can program that. So that's our first step, 3/4 inch flange. Now we got to figure out what to do next. And so right here, you know, you see we're on steps. To add a step, we're just going to do this, and it says, do you want to add a bend? And now we're at it blanked out again. Now we're going to program the next bend in, and it's going to be this one right here. So I'm just going to knock it out real quick. So it's still 120. Notice it carries over some of the information. It's still 120 inches wide. It's still got that material. It's still got all of our die information. The angle is going to be about a 15-degree angle. So 180 degrees minus 15 is going to be 165. All right. The x-axis is going to be 1 inch. It's right here. I don't have it specified right here, but this is 3/4 and this is going to be 1. The only other thing I didn't show you is the R axis, the R1 and R2. So, and R is up and down movement of the back gauge. So we covered Z, which is left and right. We covered X, which is in and out. And then now we'll look at R. So these are absolute values, the position of where they are up and down. So if we were to go and change this right here to 3.5, and change this one to 3.5, because you can change them independently. You could have one side up and the other side down, and you may need that for some type of parts. But let me go ahead and activate this. So anytime you make a change, you always have to go here and activate it with the green start button. So I'll go ahead and do that now, and you can see that raise up. Well, there it goes. So it activated the entire bend. So just to show you this again, we'll put this back down 2.41. we got that back, and now we'll go press our green start button. So that's our R axis, and it moved them both now. Cool, so let's get some stuff cut out on the laser and we'll get to bending. I'll finish up programming the rest of this and we'll see how it works out. So this is the 5-axis 6 kilowatt bevel head machine that is sold. I have a deposit from an existing customer that's going to be coming down for training, hopefully in the next couple months. And when I have the opportunity to cut something, I go ahead and do it on this laser because, you know, it doesn't have a material library built for it. So over time, just cutting a couple little things out like this, we've been slowly building up the material library for it. And as many of you laser operators know, every machine is different and you can't really just take, you know, parameters from one to the other. So this is some painted 26 gauge, just trim panel stuff that I got at the local steel yard. All right, so we were making 10-foot sections, which is what the brake is, but we got one last section that needs to be about 55 inches, so let's set the brake up for that. All right, so we got our 55-inch piece cut right here, and we really just need to run the same program, but our Z-axis is set up for 10 feet. We needed to come in to 55 inches. So you could do a couple of different things. You could go right here on the Z-axis and manually change those, or on the width of your material, we could just make this 55 inches. And then, so that's step 1 of 4. So we'll go to step 2 and we'll do that as well here, 55. We'll scroll to step 3. This is NC programming. And same thing on step 4, 55. All right, and then we'll go back to step 1. And we will go here. And it says, do you want to save those changes? Yes, we do. And then here we'll just hit the green button. So now we're set up for 55 inches. And there's our little 55-inch section.
All right, so here, what I did was I measured the profile of the end cap. Again, because I didn't draw that originally in CAD, I just freewheeled it. Who knows where it actually came out to be. So this is kind of what I got measuring with calipers. So I just drew this up, and then over here, I modeled it up in Fusion sheet metal, just added the flanges, added some holes, and this is what we got. So let's take this out, export it out as a step file, and import it into the brake.
All right, you see when we open that file, it's wanting us to be in the middle of the brake, which by default, you always kind of want to be in the middle of the brake, but a very small, thin part like this, it won't really matter. So as you can see, we got a bunch of segments down here and some segments right here. So, and a lot of long segments in this area. So rather than trying to get all that over there, I'm just going to create a little space and get it set up right here, kind of where it wants to be. So if you see here, we got the hydraulic tool clamping on this machine. So if we hit the red button here, we're gonna unlock the tooling. You can see now it's loose. So all I'm gonna do is drag some of this stuff down and create an opening right here. And then we'll grab this out. We'll push this down. Move this back a little bit. We'll pop this in here. So we'll do our bending right here. Like I said, on something small, it don't really matter. Thicker plate or something, yeah, you'd probably want to be in the middle. This machine does have obviously Y1, Y2 as part of the 8+1 axes. So you can do offset correction to factor in the off-center bending, but yeah, let me step through each step and move the Z2 over to here, and then we'll run our program right there.
All right, so here it is all finished up, and Matt's shooting some water in there, doing a little leak test. We do have fall, even though it doesn't look like it in this video. There's fall from one end to the other, and the reason that we have the leak in the first place is because that there's not much fall at all. So you can see this is taking forever to get down there. He's squirting a good bit of water in there. We're just leak testing it, and then right here, you know, we're going to kind of treat this as an AC condensate and just do a little elbow right out the building and let it go to the outside right there. And you can see the water coming in, and we don't have any leaks down through there, nothing dripping. So hopefully we got some rain coming here soon, and this will solve our problem.